Hello, ninth grade extended students. Today we are going to talk about circular functions, or what I like to call bug problems. This will be the introduction to trig. So we are going to make two functions based upon the path of this bug in the coordinate plane. The bug is going to start walking around counterclockwise around this square that has vertices at 1, 1, negative 1, 1, negative 1, negative 1, and 1, negative 1. So it is walking at 1 unit per second, and when the bug gets to 1, 0, right here at the positive side of the x-axis, we start a stopwatch. We're going to call the function horizontal of t, the x-coordinate of the bug at time t, and vertical of t, the y-coordinate of the bug at time t. Very, very quickly, I start writing h of t and v of t rather than horizontal and vertical to save a little bit of time. Just so that we all understand what's going on. Horizontal of 0, in other words, when we start that stopwatch, my bug is right here, and the x-coordinate is 1, and therefore horizontal of 0 is 1. Vertical of 0 is my y-coordinate when it's at this position, and that is 0. The time that it takes for the bug to get here from when we start the stopwatch, again, it's walking 1 unit per second. So I have 1 second, 2, 3, 4, 5 seconds. Time at that spot is 5. So if I wanted to know h of 5, I would simply say what the x-coordinate is there, negative 1. And v of 5 is the y-coordinate there, negative 1. This bug has been walking continuously even before we started the stopwatch. It's been walking since the beginning of time and will be walking long after we're gone. Negative values for t represent the amount of time before we started our stopwatch. So where was the bug at negative 1? Well, that was 1 second before I started my stopwatch. Here it was where I started. Negative 1 would be down here. So at t equals negative 1, my coordinates are 1, negative 1 at this spot. At t equals negative 5, it would be 1, 2, 3, 4, 5 seconds before we started our stopwatch, or right up there at negative 1, 1. Now we are going to find some function values. First, we're going to look at time pi. The first step is that I need to find what part of my path the bug is on at pi seconds. And we know pi is between 3 and 4, 3.14, just a little past 3. So it is going to be at 1, 2, 3, right about over here. So now I want to know the x-coordinate and the y-coordinate. The x-coordinate is my horizontal, the y-coordinate is my vertical. The x-coordinate is quite easy. I can see it's just at negative 1. It is left of my y-axis, 1 unit to the left. So the vertical of pi, I've got to figure out. It took my bug pi seconds to walk that far, or it went pi units. What I'm looking for is this distance here. That's my vertical distance. From here around to there, it is 1, 2, 3, 4 units. So this will be 4 minus pi, and that is my vertical of pi. Notice horizontal of pi is negative here. It's to the left of the y-axis. And vertical of pi is actually positive. It is above my x-axis. That's not always the case. For example, in quadrants 3 and 4, vertical of t is negative. In quadrants 2 and 3, horizontal of pi is negative. I'd like you to give these two a try. Press pause on your video. When you're ready for the answer, press play again. Here are my answers. Again, we want to figure out where that bug is. The bug has been walking square root of 2 seconds. So you've got to figure out where square root of 2 is. Think about perfect squares. Square root of 1 is 1. Square root of 4 is 2. Therefore, square root of 2 has to be between 1 and 2, with square root of 2 being closer to 1 than it is to 4. So square root of 2 is right here. So I've gone 1, I've gone a little bit more than 1, and the horizontal is going to be this distance right there. So it would be 2 minus the square root of 2. That's this distance, and it's positive right there. Vertical of square root of 2, pretty easy. How far above the x-axis is it? Exactly 1 unit. Okay, here are my answers. First, I had to figure out where that bug was. Square root of 7 seconds later. And square root of 7 is somewhere between 2 and 3, because square root of 7 is between square root of 4 and square root of 9. So somewhere over here. So the next thing I need to do is figure out what my horizontal, or my x and both my x and y coordinates are here. So from here to here is square root of 7 units. From here to here is 2. This distance is square root of 7 minus 2. But x is negative in quadrant 2, and therefore the horizontal is the negative of that quantity, and that negative gets distributed in. My vertical of the square root of 7 is 1. It's 1 above the x-axis. Next, I would like to find horizontal of 4 square root of 2 and vertical of 4 square root of 2. Just as before, we need to estimate where that is. The easiest way to do it is to think about how the square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, square root of 36 is 6. Now, 4 root 2 is kind of hard to interpret, but if I change it so the 4 is underneath that radical, it makes it easier. 4 square root of 2 is equal to the square root of 16 times the square root of 2, which is equal to the square root of 32. Now, looking at that, I can see that 4 square root of 2 is somewhere between 5 and 6. It's between square root of 25 and square root of 36. So, if it's between 5 and 6, let's see where that bug is. 1, 2, 3, 4, 5. Oh, it's somewhere over here. Now, I'd like you to find the horizontal of 4 root 2 and the vertical of 4 root 2. When you're ready for to check your answer, press play again. Here are my answers. So the horizontal is going to be the distance to the left of this y-axis. I know from here to here is 4 root 2. And I know from here, 1, 2, 3, 4, 5, 6 is 6. So this distance is 6 minus 4 square root of 2. But my coordinate is negative here. So I have to take the opposite of all of that. So it's minus 6 plus 4 square root of 2. My vertical is my y. That's 1 unit below, so negative 1. Next, I'd like to graph horizontal of t. I'm going to put that on my y-axis and t on my x-axis. And we are going to plot our x-coordinates against time. So at time 0, my x-coordinate oops, my x-coordinate is 1. It's 1, 0 here, 1, 1, 0, 1, minus 1, 1. Over here, it would be minus 1, 0, minus 1, minus 1, 0, minus 1, and 1, minus 1. So let's keep graphing. So at time 1, my x-coordinate's still 1. I'm going to plot that. At time 2, my x-coordinate's 0. At time 3, my x-coordinate is negative 1. And then it stays negative 1 at 4 seconds and also 5 seconds. And then at time 1, 2, 3, 4, 5, 6, my x-coordinate is 0. At time 7, my x-coordinate is 1. At time 8, my x-coordinate is still 1. And now it's gone 1 full revolution. So my graph looks like this. And then it's going to repeat. That bug's going to repeat this pattern forever. So that's h of t. Now this is what we call a periodic function. That means that the y values repeat at regular intervals, and my period is the number of x units it takes before my y units repeat. So my period here is 8. Every time I go out 8 units, the pattern of my y's will repeat again. My domain is all real numbers, and my range is from -1 to 1. Next, let's graph v of t. So now we're graphing our y coordinates against time. My ordered pairs are just like they were before. 1, 1. This one is at 0, 1. And -1, 1, -1, 0, and then -1, -1, and then here is at 0, -1, and then finally at 1, -1, and then it's going to go back up to 1, 0 and repeat. So we're going to graph v of t on the y-axis, and we're going to graph time on the x-axis. So at time 0, my y-coordinate is 0. So 0, 0 is on my graph. Then in 1 unit, or 1 second, my y-coordinate is 1. It's plotted there. And then 2 seconds, 3 seconds, it stays at 1. 2 seconds, 3 seconds. And then once it gets to 4, my y-coordinate is back at 0. And then at 5, it's going to drop to -1. And then it's going to stay at -1 at 6 and 7. And then at 8 seconds, it's going to be back up at 0. And my graph of v of t will look like this. And then it's going to repeat. And it will repeat forever. You get the idea. So, just like the last one, this function's periodic. It takes 8 units of time before my y pattern repeats. So my period is 8. The domain is all real numbers. The range goes from -1 to +1. So just to say this again, my period for each of these functions is 8, both for h of t and v of t. And the domain for each, all real numbers, and the range for each is -1 to 1. Now looking at each of these functions, I'd like to ask if they're onto, one-to-one, a permutation, are they invertible? Now onto means that every single y value in real numbers has an x value that gets mapped to it. This is not onto. Each of them only covers these values of y. So from -1 to 1. It's not on to real numbers. Is it 1-to-1? No. To be 1-to-1, it would have to pass the horizontal line test. To be 1-to-1, I can't have more than one x value mapped to the same y value. So you can see here, this is absolutely not 1-to-1. It doesn't pass the horizontal line test. I'm going to draw myself a horizontal line so you can see this is the vertical of t. And you can see that here's an x value mapped to that y. Here's another x value mapped to the same y. Another x value mapped to the same y. To pass the horizontal line test, any horizontal line you draw on a graph can intersect at most one place. Neither of these is 1-to-1. So in order to be a permutation, it has to be onto, it has to be 1-to-1, it has to be from all real numbers. This is not. And the reason that this is important is that in order for a function to have an inverse function, it must be 1-to-1. So these functions are not invertible. And that's going to create a problem for us. Now, luckily, we can restrict the domain on each of these in such a way that we will be able to find a 1-to-1 section and create an inverse function. Remember, inverse functions change your x and y values. So x gets mapped to y in the inverse function. That y value gets mapped back to x where it came from. So again, we are going to restrict the domain on each of these functions in such a way that it's 1-to-1, and we can create an inverse for each. Now, there are infinitely many 1-to-1 sections we can choose on each of these functions, and because of that, mathematicians have come up with a way to be consistent and choose the same 1-to-1 section as they are looking at functions. And the rules go like this. You must choose part of the domain that covers all possible y values. You must, if possible, include x equals 0. Sometimes it's not possible, but when it is, you should choose it. And then if there's still a choice, you should choose the smallest positive x's. And you should follow these rules in order. So let's look at h of t first. We want to find an interval of x's so that we cover all the y's and it's 1-to-1. Now, there are several sections. This would be a section that covers all the y's from -1 to 1, and it is 1-to-1. I have this section here, and this section here, and infinitely many. So here are three possible choices. I could choose the x values from -3 to -1. I could choose the x values from 1 to 3 or 5 to 7. None of these include 0, which was my second rule. If I can include 0, I should. That's not possible. So unfortunately, our inverse won't contain x equals 0. The smallest possible x's are what you choose when there's still a choice. So the smallest positive x's go from 1 to 3. So we're going to restrict our domain between 1 and 3 seconds for the purposes of finding an inverse function. Now let's find the restricted domain for the vertical of t. Same idea. You want to cover all possible y values and choose a 1-to-1 section. That covers all my y values from -1 to 1, and it is a 1-to-1 section, so it could be there, it could be here, It could be here. It could be here. There are infinitely many one-to-one sections I could choose. So I have some listed here. Now, the next rule is that you should include x equals 0 if possible. Well, it is. The interval between -1 and +1 is a one-to-one section, covers all the y's, and it includes x equals 0. That's the one I want. So when we're restricting the domain for the vertical of t so that we can find an inverse, this is the restriction. So let's find some inverse horizontal function values. Now remember, we're switching our domain and my range. So what this says is, what time is it when the bug is at the x coordinate? So what's inside these parentheses is no longer the time. It is the x coordinate. That is the input. And the output is going to be the time. Now, the restriction on the horizontal of t domain, you have to know it's between 1 and 3. So if you think about it, we have h of t, our domain was all real numbers. Our range went from -1 to 1. So that it would have an inverse, we restricted the domain to be between 1 and 3, and this should say less than or equal to there. So when we find our inverse domain and range, it flips. The domain of my inverse function has to be the range of my function. The range of my inverse function is the restricted domain of my function. So now as I look at these values, my output has to be in the range. So I'm looking for values of time only between 1 and 3, and that's going to be this upper path right there of my square. So we are going to locate the bug, and then we're going to figure out what time it is. So my inverse horizontal of 0 says my x coordinate is 0. So as I look at this path, the x coordinate is 0 on the highlighted path right here. The time is 1, 2 seconds. So inverse horizontal of 0 is 2. And again, it has to be in this range. The next part, the next one, is inverse horizontal of 1/2. My x coordinate is 1/2 right there. And now I have to say, what time is it? And the time is 1 plus 1/2, or 3/2. Next, let's find inverse horizontal of 1. My x coordinate is 1. That's right there. What time is it? The time is 1. It takes 1 second to walk to this position. Then I want to find inverse horizontal of 2. So we have to say, where's the bug when the x coordinate's 2 along this path? Answer, it never is 2. The highest that x value can be is 1. So this is undefined. Now let's find some inverse vertical values. Now remember, it's the inverse. So this value that's inside the parentheses is the y-coordinate of the bug. That is the y-coordinate. The output is the time. What time is it when the y-coordinate is -3/4? And for this, we have to consider the restricted domain on our vertical function. So I have it highlighted here. You can see it's between -1 and +1. So the domain of inverse vertical is going to be between -1 and 1. That was the range of my function v. And the range is going to be my restricted domain of my vertical function, which goes from -1 to +1. And that means my bug is on this part of the path here. So, inverse vertical of -3/4. Well, that means it must be down here. So -3/4 is there. And the question is, what time is it? Well, I have to answer something between -1 and +1. This was 3/4 seconds before I started the timer. So the answer is -3/4. Why don't you press pause on your video and try the last 3. And when you are ready to check your work, press play again.